In a recent earnings call, Elon Musk affirmed that 2025 will be the year of the low-cost automobile. This has rekindled discussion regarding the Tesla Model 2, which was previously thought to be scrapped. The resurrection of the Model 2 has sparked widespread enthusiasm among Tesla fans and analysts, particularly when whispers about the Redwood project first surfaced. Specifically, a Model 2 Redwood with a price of under $25,000 and high quality has been expected to be Tesla's next revolutionary breakthrough in the electric vehicle business. But how can Tesla provide all of this for such a low price? What is the secret behind the Model 2, making it a genuine revolution in electric vehicles? In this video, we'll discuss everything from whether the Model 2 Redwood is still being built to why the car's quality is still assured at such a cheap price. But first, stop the video and click the subscribe button to support our channel. We make sure you don't miss any Tesla news, including the Model 2 Redwood. What do Tesla's latest measures reveal about the Model 2 Redwood scenario? So, in the car industry, we are still on pace to provide more economical models beginning in the first part of 2025. That's what Elon Musk stated during the third quarter earnings conference. He made a crystal clear statement emphasizing Tesla's commitment to make EVs accessible to the general public. Other Tesla executives confirmed this week that a new low-cost car is in the works and would be available in the first half of 2025. During the call, Ashok Elluswamy, Director of Autopilot Software at Tesla, indicated that we are working on cheaper models to be released. He also stated that teams are now working to prepare the factories in order to make this happen. These actions indicate that the introduction of Tesla's low-cost electric vehicle line in 2025 will paint a very different image. Elon Musk provides some of the most concrete proof. Musk has officially disputed allegations that Tesla is discontinuing the Model 2 in favor of its robo-taxi. On April 5, 2024, Musk replied to a Reuters claim by declaring that Reuters is lying again and reaffirming Tesla's commitment to the Model 2. Musk's forceful denial emphasizes the company's dedication to the Model 2. Given Musk's history of open communication, his public rejection carries significant weight and explicitly contradicts the reports. Tesla's fast expansion of its Gigafactory network is another critical aspect. Tesla's Gigafactories are the acme of modern industrial efficiency. These facilities are more than just production factories. They are fully integrated production ecosystems that aim to optimize all aspects of automobile manufacture. For example, Giga Texas, one of Tesla's flagship plants, runs at breakneck speed, producing a vehicle every 40 seconds. Tesla's utilization of sophisticated robots, AI-driven assembly lines, and vertical integration tactics that minimize manufacturing bottlenecks has resulted in increased efficiency. The utilization of single-piece casting for massive automobile components, enabled by Tesla's own Geiger press equipment, is a notable advance. By lowering the number of parts and assembly stages, this technique reduces production time while enhancing vehicle structural integrity and safety. Such speed and precision are required for high-volume production of a car like the Model 2, which is aimed at the mass market. Traditional automakers struggle to compete with this level of efficiency because they often use slower, more fragmented processes that include several suppliers and assembly locations. In November 2020, General Motors grappled with a massive recall of the Chevy Bolt EV owing to battery concerns tied to its supplier LG Chem. The recall expanded in August 2021, costing around $1.9 billion and affecting GM's manufacturing timetables. Tesla's plants are built to perform everything in one location, from battery cell manufacturing to final car assembly. This integrated strategy not only saves time, but also reduces costs, allowing Tesla to create a high-quality electric vehicle at a price point that competitors can only dream of matching. Tesla's industrial approach is also extremely adaptable, allowing the firm to quickly shift resources and meet shifting demands. For example, when faced with supply chain restrictions or market disruptions, Tesla may reallocate manufacturing capacity among its worldwide gigafactories to ensure consistent output. This adaptability guarantees that Model 2 production stays feasible, even during difficult economic or political times. While manufacturing speed is important, battery technology is the source of energy for all EVs. Tesla has made significant investments in battery technology, cementing its position as a market leader. Tesla's recent development of the 4680 battery cell and solid-state battery cell demonstrates the company's dedication to cost reduction and innovation. These new cells outperform their predecessors with a greater energy density of 20 to 30%, allowing for a 400-mile range and enhanced performance in a smaller, more economical packaging. The bigger format of the 4680 cells simplifies the battery pack's architecture by lowering the number of components and assembly stages necessary. Tesla's vertical integration in battery manufacture is another important consideration. Tesla avoids the high costs and supply restrictions that come with using third-party vendors by making battery cells in-house. This technique not only guarantees a consistent supply of batteries, but also provides Tesla total control over the cost structure. Furthermore, Tesla's gigafactories are intended to produce batteries at unprecedented scales. For example, Giga Nevada's highly automated production lines and optimized procedures will allow it to generate enough batteries to power millions of vehicles each year. When we examine the speed and efficiency of Tesla's plants, as well as its battery manufacturing advancements, it is clear that the Model 2 Redwood is not only achievable, but also a logical extension of Tesla's commitment to expedite the world's transition to sustainable energy. So, do you believe Tesla can produce a high-quality, inexpensive EV without sacrificing range or performance? Please explain your explanation below. In the following section of the movie, we will address a question that many people will undoubtedly be interested in. But first, take 2 seconds to click the subscribe button. How can Model 2 Redwood reach such a cheap price of $25,000 while maintaining quality? Tesla's target of pricing the Model 2. Redwood at $25,000 is a significant step forward in making electric vehicles more affordable to a wider market. This lofty pricing is achieved by a mix of manufacturing innovation, smart material selection, and economies of scale, all of which enable Tesla to provide competitive quality and performance. When compared to other vehicles in the US market, the Model 2 Redwood's cost is revolutionary. At $25,000, it undercuts not just EVs like the Chevrolet Bolt, which costs $26,500, and the Nissan Leaf, which costs $28,000. This inexpensive pricing makes the Model 2 an enticing option for budget-conscious purchasers, especially given the lower running expenses of EVs. Model 2. Redwood also has a better design than other automobiles in the same class. Its appearance is likely to follow Tesla's minimalist and aerodynamic design philosophy, which maximizes range while lowering material costs. Tesla uses aluminum extensively in its chassis and subframes. Advanced die-cast aluminum alloys developed exclusively for Tesla enable lightweight and robust construction. Tesla's mega-casting technique may minimize the amount of parts and complexity, considerably lowering production costs. Aluminum is also employed in external body panels since it is both lightweight and strong, as well as corrosion resistant. This improves safety and durability without increasing weight or expense. In contrast, vehicles like the Hyundai Kona EV are primarily reliant on steel and traditional assembly methods. While steel costs 2 to 3 times less per kilogram than aluminum, its heavier weight can offset energy efficiency advantages and raise expenses due to the complexity of various suppliers. Furthermore, Kona's emphasis on traditional utility features, such as a bigger cabin and ample luggage room, raises manufacturing costs through additional materials and assembly complexity. From the inside, the Model 2 is expected to include Tesla's signature sleek layout, highlighted by a single touchscreen that replaces the need for physical buttons and knobs. This design not only complements Tesla's futuristic style, but it also simplifies production when compared to competitors such as the Chevrolet Bolt EV and the Nissan Leaf. Their designs frequently use more traditional dashboard layouts. In particular, these vehicles continue to employ physical controls for temperature control, audio, and navigation. While the Leaf incorporates contemporary technology, the dashboard remains a conventional form meant to appeal to a wider spectrum of drivers, particularly those unfamiliar with touchscreen-based systems. In terms of technology, Tesla's software-driven approach provides tremendous value to the Model 2. Over-the-air upgrades enable Tesla to constantly enhance car performance, address faults, and even introduce new functions without the need for physical alterations. This lowers long-term expenses for customers and sets Tesla apart from competitors such as the Chevrolet Bolt, which lacks comparable software capabilities. Furthermore, Tesla's integrated hardware and software ecosystem ensures that even low-cost models benefit from sophisticated driver assistance functions, albeit in restricted capacity compared to premium Tesla models. Tesla's pioneering use of die-casting technology, facilitated by devices such as the Gigapress, is critical to the Model 2's cheap cost. This method speeds production by combining hundreds of discrete components into a few big modules. For example, the Model 3's underbody necessitates considerable welding and assembly of multiple tiny components, but the Model 2 uses large-scale casting to create a nearly complete chassis in fewer steps. Tesla may considerably reduce manufacturing expenditures compared to competitors like as General Motors and Ford, who still use more traditional assembly line processes. Tesla will provide a breakthrough alternative for people wishing to transition to electric vehicles without the significant upfront cost associated with EVs by charging $25,000 for the Model 2 Redwood. This low price will make Redwood more appealing to a wider group of buyers, including those who had previously considered only traditional gas-powered automobiles. Tesla's simplified design strategy, which emphasizes a minimalist interior centered by a single touchscreen, lowers production costs and complexity. Furthermore, buyers may be able to take advantage of special offers such as trade-in discounts, referral incentives, or even free supercharging for a limited time, lowering the overall cost of ownership. Tesla's continuous commitment to over-the-air software upgrades will also ensure that customers receive continual improvements in vehicle performance and functionality at no additional cost. That will be a significant advantage of buying a Tesla Model 2 Redwood. So today, we've been listening in to our in-depth look at the 2025 Tesla Model 2 Redwood, a game changer that's rewriting the future of electric automobiles. Electric vehicles will undoubtedly become more inexpensive than ever in the near future. Now, we want to hear from you. Do you believe the Model 2 Redwood will dominate the EV market, or will competitors up their game? Which feature excites you the most, and what would you like to see Tesla implement next? Please share your ideas in the comments below. If you enjoyed this video, please like it and subscribe to our channel so you don't miss out on future releases. We have some great things heading your way, so stay tuned.